Okay, so the first one, hopefully kind of easy. We know where sine equals root 2 over 2. And also notice that it tells us we want all answers. Okay, so we're going to have the plus 2 pi n thing here happening. So sine equals root 2 over 2. We want to go from 0 to 2 pi, and it's going to happen at pi over 4 plus 2 pi n. And again in the second quadrant with the reference angle pi over 4, which is 3 pi over 4. Okay? Number 2 is a super oddball question that I'll probably never ask you again, but there's no like algebra or anything to do here. You just need to know where they equal the same thing, and there's one angle in the first quadrant where they're the same thing. 45 degrees, but in radians it's going to be pi over 4 plus 2 pi n, okay? And they're also the same thing in quadrant 3 again, where they're both negative. It doesn't happen in quadrant 2, because sine's positive and cosine's negative. Okay? What's up, Albert?
I have a question, a couple questions on the math.
All right, man.
I mean, finish your lesson, go ahead.
Okay.
That's
And
all
5
you-
pi over 4, because they're both negative root 2 over 2 there. And that really is, there's no like math there. I mean, there's math, obviously, but you have to just know the unit circle for that. Okay. Where does tangent equal 1? That happens at, actually, the same exact answers. Pi over 4 plus 2 pi n and 5 pi over 4. It's in the third quadrant where tangent's positive, okay? These also happen to be, you can rewrite both of these together as one. You don't need to do this, but this is also the same thing as just pi over 4 plus pi n, because pi over 4 and 5 pi over 4 are pi apart. So if you were to take pi over 4 and 5 pi over 4, if you add pi, you get this one. If you add pi again, you get this one. Add pi again, you get that one. Okay? But really, so this method will always work, though. Find them all between 0 and 2 pi, add 2 pi n, done. Okay. Go ahead. So this is one where we got the cosine squared and the sine, so we're going to have to use one of our Pythagorean identities. Okay? So we got to get rid, because it's not like a GCF thing, right? We got a squared and one's not squared and a 1. So because we have a sine and a cosine squared, we're going to use the Pythagorean identity. That is sine squared theta plus cosine squared theta has to equal 1. And later I will, yes. Okay? They just come from the Pythagorean theorem, really, but we'll talk about it. So that has to be true. That's just true for all angles. Okay? So what that means is, because I have a sine theta here, I'm kind of stuck with it. But a cosine squared, I can use this equation here to solve for cosine squared. Cosine squared is going to equal 1 minus sine squared. Is that okay? I'm just subtracting sine squared from both sides. Okay? And because that's what cosine equals, or cosine squared equals, everywhere in the equation above where I see a cosine squared, I can put a 1 minus sine squared. Is that okay? So the left-hand side is staying the same. Because cosine squared equals 1 minus sine squared. The left side stays the same. Yep. But the right-hand side, which used to be 2 cosine squared theta, is now going to be 2 times 1 minus sine squared theta. And the whole point of doing that is now I have all sines to deal with as opposed to sines and cosines. All right? Now all I'm going to do is simplify this down, get everything, because I still have a squared and I still have a sine, right? So I'm going to have to factor it either way. But you can't factor it if you have a cosine squared and a sine, unless it's like a GCF going on. So this is going to be 1 plus sine theta equals 2 minus 2 sine squared theta. Is that okay? And then I'm going to move that stuff all over to the other side to have just one side here. So that is 2 sine squared theta plus sine theta minus 1 equals 0. Okay? I'm subtracting 2 from both sides, which gives me a negative 1 on the other side. And I'm adding 2 sine squared to both sides, which makes it positive on the left. Okay? And now this looks like a quadratic, but instead of having like 2x squared plus x minus 1, we have sines in there. We factor it just like they were x's. So there's going to be two sets of parentheses, and it's going to be 2 sine theta. There's going to be a sine theta here. And we got to make sure we factor it correctly so we get that plus 1 sine in the middle. So this one needs a plus 1, and this one needs a minus. Whoa, needs a minus 1. Is that okay? And that gives us, so now we have two things being multiplied to get 0. So either the first one is 0, which only happens when sine is a half. Cool. And this one happens when sine equals -1. Okay. And now we just have two equations that we have to solve at this point. But it's all from the unit circle, which is what we wanted. So either theta equals, to equal a half, we have pi over 6 plus 2 pi n, or theta could equal 5 pi over 6 plus 2 pi n. Is that okay? That's from the 1/2. That's where sine equals a half.
Yeah.
And then we also got to list out where sine equals -1. And that happens only at one place between 0 and 2 pi. And that's 3 pi over 2. Okay? So those are our three different answers. It's actually infinitely many answers, but they all come from 3 answers in 0 to 2 pi. Okay? And that's how you use trig, the Pythagorean identities. Okay? So, but you only need to do it, again, notice the pattern here, when we have a trig function and then a different trig function squared. Cool?
Okay.
So, over here, number 5, we don't have to do it. They're both cosines, 1 squared. And there's no constant, right? We're not adding anything. So here, this is just the GCF one. We can just pull the cosine out. And when you do that, you get cosine of theta times 2 cosine theta plus 1 equals 0. Albert, what's happening, man?
I don't know how to solve this.
I'll distribute, brother. That's not a U to U. That's power rule, yeah.
Oh.
Okay with this? Took out the cosine theta.
Then one of them has to equal 0.
Because we're multiplying to get 0. So yeah, if this equaled a number on the other side here, we have to move the number over and then factor like a quadratic. So either cosine theta is 0, or 2 cosine theta plus 1 is 0, which means cosine theta would be -1/2. Oh yeah, man. Cosine theta is 0 when theta is pi over 2 plus 2 pi n, or when it's 3 pi over 2 plus 2 pi n. Cosine theta equals -1/2 at what? 2 pi over 3 plus 2 pi n. And in the third quadrant, which would be 4 pi over 3 pi n.
So you wouldn't do this by just knowing your unit circle.
Yeah, so the whole idea is to get the trig equations by themselves, and then there's no math you can do there. You can draw your special right triangles, I guess, and try to figure it out a little bit, but really it comes down to knowing the quadrants and then the angles where they equal those things, the unit circle. Okay? So this is the first one we got that has a number next to the theta. We treat it like normal. Forget the 3's there for a second. Where does sine equal -1? When the thing that's inside of it, so not theta anymore, but 3 theta, is 3 pi over 2 plus 2. You are some angry calculus students over here. My God, calm.
Oh, I'm sorry.
You're hostile.
X times x -1 is
1.
1.
It's x to the 0, which is 1. Yep. Okay, are we okay with this? 3 theta has to equal this thing.
Yeah.
This would be the best YouTube video ever. Okay?
Yeah.
And so we didn't do anything different. We just left the 3 theta alone. But now to solve for theta, now you divide by 3. So you don't do anything to what's inside the trig function until the trig function's gone. So we do everything the same and then get rid of the 3. So we're going to divide everything by 3, and that gives us pi over 2 plus 2 pi n over 3, or 2 pi over 3n, same thing. Cool? Okay.
That's it?
That's the answer. Yeah. So if it said give the answers that are in this interval, we'd have to like let n be 0, and then 1, and then 2, and list out all the ones until we get past the interval. Cool. Number 7, we could factor like a difference of two squares. Remember that, like a squared minus b squared factors? Or, you notice there's only one trig function there?
Yeah.
Just get it by itself. That's the same thing as saying sine squared equals 1. And then take the square root of both sides. Just keep in mind when you take the square root, you get plus or minus 1.
Definitely.
Yeah.
That's for the first one.
So theta would have to be, these answers are online, man.
They are?
Yeah. So to equal positive 1, theta would be pi over 2 plus 2 pi n. To equal negative 1, sine hits that at 3 pi over 2.
Why?
Why? Because the unit circle, sine is the y value. You can also think of what the graph of sine looks like. Like, remember sine goes up and then down, then back up again? It hits 1 here at pi over 2. This is pi, 3 pi over 2, 2 pi.
Oh, okay.
Okay? But that really all just comes from the unit circle. Okay. Well, let's continue. What does cosine equal? A half? Well, we need what's inside of cosine to equal either pi over 3 plus 2 pi n, or we need what's inside to equal cosine's positive again in the fourth quadrant, which gives us 5 pi over 3. Is that the homework from last night, man? I think you're doing, yeah, you might have to open up, I think you're doing the third one, yeah. Okay, but we're not done because we got to find theta, so we got to divide by 2. When you divide by 2, you get theta equals pi over 6 plus pi n, or theta equals 5 pi over 6 plus pi n. Cool? All right. And then over here. So this is one where I could have given you, if there's a sine and a sine squared, I could have gave you a cosine squared too and had you switch it out using Pythagorean identities, all right? But the sine squared and sine, we factor it like normal. This is the same exact equation that was up here, is it? It's awfully close. Oh, that was 2 plus minus. This is 2 minus minus, okay? So we factor it, like a quadratic equation.
Oh.
So it's 2 sine theta here, and then we know there's going to be a sine theta here. We know it's going to equal 0. We got to find, again, multiply negative 1, but we got to get that negative 1 sign in the middle, which means we need to have a minus 1 here, plus 1 here. So this is very similar to the one that we did before. Okay, yeah. So either sine theta equals negative a half, or sine theta equals 1. Okay, and that only happens when theta is, for negative a half, that's 7 pi over 6 plus 2 pi n, or 11 pi over 6. Explain to me again why I'm putting these plus 2 pi n's here.
Because every time you go around a circle, you do the same thing.
Hey, all right. Not the same angle, the same y value really, but coterminant. There you go, exactly, okay? Exactly. Good. Plus 2 pi n. Who is this? Clowns. All right. And we did number...
What's the last one? 11 times?
What's up, Cecil?
I made the tape
Oh, cool, man. Give me a second here. All right, was number 10 the last one we did? Did we do a 12?
I didn't, but I might have done it wrong.
Okay. All right.
But I
Okay. Well, we can go through. I mean, these aren't going to be anything crazy difficult. Let's just do 10, 11, 12. So the 4 is in there, but it doesn't matter right now because it's in tangent. Tangent hits negative 1. At what?
It's like number 6, like you do the same.
Yep. So 4 theta. Tangent hits negative 1 in the second quadrant at 3 pi over 4. And again in the fourth quadrant at 7 pi over 4. Cool? And that's what the angle has to equal, but remember the angle is really 4 theta. So to find theta, divide by 4. And when you do that and reduce it, you get 3 pi over 16, and 2 divided by 4 is a half, so that just becomes pi n over 2. Okay? And this becomes 7 pi over 16 plus pi n over 2. All right, so not too bad. And number 11, same thing, get tangent by itself, so take the square root. Just remember, when you take the square root, you get plus or minus. So I need to know where tangent equals root 3 or negative root 3. That happens 4 times, once in every quadrant, right? Because it's either positive or negative. So it's going to happen when the inside angle, which is 3x in this case, is pi over 3 plus 2 pi n. It's going to be positive again in the third quadrant, which would be 4 pi over 3 plus 2 pi n. Cool? It's going to equal negative root 3 in the second quadrant, so that's going to be 2 pi over 3 plus 2 pi n. And again in the fourth, which is 5 pi over 3, and then plus 2 pi n. Whoa, shit. Okay? And then all we got to do is divide by 3 to get them all. So x equals pi over 9 plus 2 pi n over 3, or 4 pi over 9 plus 2 pi n over 3, or x equals 2 pi over 9 plus 2 pi n over 3, and the last set of answers is 5 pi over 9 plus this. Cool? So we have these two sets of answers right here, and we have these two sets of answers right here. Okay? And then the very last one, although it looks different because there's like an x over 2, we handle it the same exact way. Instead of dividing by 2 to get x, we're going to multiply by 2. All right, when we get to the x over 2 equals thing. So anyway, we got to know where cosine equals root 2 over 2. Well, that happens when the inside angle, which is x over 2, is pi over 4 plus 2 pi n, and it happens again when the inside angle is 7 pi over 4. And to solve for x, I'll do it next to it here. We just multiply by 2 now instead of dividing because it's a fraction, okay? So we're going to get x is equal to pi over 2. Get out of here. What is this? Get out of here. Plus 4 pi n. Yep. Or x equals 7 pi over 2 plus 4 pi n. All right.